Hey scholarship kids, and welcome back to lesson 3 part B. This will be a nice quick video because it's just this final question, and that kind of wraps up the first section of the redox that we've been covering. So this is from a 2005 exam. It says account for the observations that platinum metal, okay, that's critical, platinum metal reacts with aqua regia, a mixture of hydrochloric acid and nitric acids, but not with concentrated hydrochloric acid or nitric acid individually. So the first thing that you need to understand is it says platinum metal. So because it says platinum metal, the metal must be getting oxidized. Because here's platinum metal, and there's only two reactions that actually have platinum metal. So that's a really big helpful hint to start with. How I've chosen to answer this question is to start by doing balanced equations and Hénault cells for the platinum metal and the individual reactions of hydrochloric acid and nitric acid. So hydrochloric acid is HCl and nitric acid is HNO3. So there's kind of three different equations that you need to do. You've got H plus here, so that's actually the H plus from here and the H plus from here. So you need to react platinum metal with H plus first of all, this reaction here, to see it if it'll occur. So platinum has to get oxidized because it's stating that you're starting with platinum metal, and therefore the H plus has to be getting reduced. So that's the first balanced equation that I would do. The second balanced equation would be with the nitrate ion. Okay, so here's nitrate here, you can see that. And again, it would be with platinum getting reduced. Now the chloride one, which is your last species left, is a little bit more complicated because if you look, there's no half reaction with just chloride. And so what that reaction is, if you just look carefully and you were trying to problem solve what it could be, this third reaction contains chloride and platinum, okay? And then you would react it with H+, and that would be the third reaction there of HCl. So that means that you've done H+ and platinum, which is this H+ and platinum. Then you've done nitrate and platinum, and then you can do this last one of H+, chloride and platinum. But I'll show you my answer, so hopefully it makes a bit more sense. But that's the process that you need to do, is you have to read the question. It says platinum metal, there's only two reactions with just platinum metal in it. You know that they have to be getting oxidized if you're starting with platinum metal, and that kind of feeds you through to the response. Okay, so here's my first one where I've put platinum and H+ together, and that's a fully balanced equation. Remember, your equations have to be fully balanced to get full marks. I'm not going to go through how to balance those equations. If you're a scholarship kid, you should be able to do those. Reduction minus oxidation, and you end up with a negative value. Okay, and because it's negative, it's not spontaneous, so it will not occur. The second one I've done is between platinum and the nitrate. Again, this is a fully balanced equation. Please go, you'd have to balance that yourself. I'm not going to do it. If you've got some questions, you can ask, but you should be able to do that. And you'll see again that the cell potential is less than 0. You could actually work that out. I've been a little bit lazy, but if it's 0 minus 1.18 up here, that's negative 1.18, and here you guys can do that negative value as well, and therefore it's not spontaneous. This one's probably the hardest one that you had in this one here. You had to reverse that equation that was the platinum and chloride and then add in the H+, and that was just by process of elimination. That's what you were left with, so that's what it had to be because it was the only other equation that had chloride and platinum in it. So hopefully that makes sense. So once you've balanced that out, you can then do reduction minus oxidation, and again you'll see that it's not spontaneous. So therefore what each of these equations is showing is that platinum metal will not react with HCl on its own or HNO3 on its own. So hopefully that makes sense. And now we've got to finish the answer as to why it will react when you've got a mixture. So when you've got a mixture, folks, which is called that, aqua regia, okay, or regia, people say it all different ways. By process of elimination, if you go back and have a look at the slides before, which I'll go back to the equations, you can see here that you have to have platinum, you have to have chloride, you have to have H+, and you have to have nitrate. So it actually doesn't leave very many options that you were given to start with. So if you look at these equations here, we're trying to find equations that'll have nitrate, H plus, and chloride. And if you look at all of them, if we put these two together, then that will contain all of those species that we need to. Nitrate, H plus, platinum, and chloride. And therefore, that's how by process of elimination, you know that we have to add these two together. Okay, so that's what I'm going to do. Okay, here's the fully balanced equation. Now remember, you have to start with platinum. So you always know which one's getting oxidized and which one's getting reduced, because the question initially started by saying that you had to use platinum. So we knew platinum had to be on the left, and therefore the rest becomes pretty easy. You just reverse the other one and balance. And once you do the cell potential for this one, you see that it's greater than 0, and therefore it is spontaneous. So it will react when you've got a mixture, just not when they're individual. Now this last part here is the fact that this is a reaction that can further occur from what we've had. Now this part here, I don't know if it was essential that you do this, but they did give the cell potentials for this, so we can do it. What you'll see is the nitrate and this reaction here, and they've added in the last one saying that just to see if this other reaction would occur. So I'm just going to go back now. Okay. So we've worked out that these two will work, and so now the last final step is why have they given you this last reaction here? Okay, this one and this one. And it's just simply adding in the reaction that we just did between these two and this here to see if it will further react. And that's all they've done in this final step to work out whether that process can occur. Okay, so this final reaction is by turning this into this with nitrate. So it's just seeing if any other reaction effectively is possible. So if any other one of these will produce a positive cell potential. And actually it turns out if you react these two together, you will get a cell potential greater than 0, and therefore it is spontaneous. So if you have nitrate ions and chloride ions, they'll actually be able to oxidize this to this. So hopefully that has made sense. So that's just a final reaction showing there's one more possibility that will be spontaneous. And if it's spontaneous, it will actually happen. So because we've got nitrate and chloride ions producing this, that means that this will actually further react to this. It probably is actually quite important. Hopefully that makes sense. If it doesn't, just let me know on Teams, because that is the final part for today before we move on to lesson 4 on titrations. Okay team, see you soon.